In this tutorial, we'll be reconstructing the patch that you see here. This should provide you with all the tools that you need to build your own granular synthesizer in Max. Along the way, we'll learn some tips for using multi-channel objects, and we'll also be patching the majority of the logic inside Gen, which is a very efficient and easy way of performing calculations on single samples of audio. I won't go into much detail about what granular synthesis is. There's loads of information in books and other YouTube videos about that. I'll include some links in the video description below. First, I'll just have a quick play around with the patch to show you what we'll be making. So here's a sample. I'll drag it into this buffer here. I'll bring the volume up. And notice as I drag this position slider across, we're getting a kind of time stretching effect. Now I can control the pitch. Back to the original. And now, so the grain is kind of frozen. If I add some spray, the playback position is randomized slightly. And the more I drag the spray up, the more randomization there is. And if I increase the spread, there's some pitch randomization as well, creating a kind of chorusy effect. It's very wide. And this group of objects here randomizes the panning position of each grain. Now if I use this XY pad, I can control the position and the pitch at the same time. Sounds a bit cooler on a drum loop. Yeah, you can get some really interesting textures there. So we'll start with a completely blank project. So first we'll create our easy DAC and a live.gain. We'll need two buffers. One to store the sample, and one for the envelope of the grain, the amplitude envelope of each grain. We're actually going to borrow the amplitude envelope from a help patcher, and you can do that by creating a gen object. Notice there's no tilde at the end there. So just a max gen object, and if you open the help file and go into gen with buffer, and then copy this here, and I'm going to copy that buffer as well. So copy all that, close it, and paste it into your patch. So click the bang here, and if you double click on the buffer, you should see something like this. So we'll have this amplitude envelope for each of our grains, which is a nice gentle curve, and it should minimize all the pops and clicks. So we have our two buffers. Now we need some way of creating a trigger to generate each grain. And the rate of this triggering is generally referred to as the density. So So we'll create a float object here, and we'll send that to an mc.phaser, and we'll make it 30 channels. And here's a scope so you can see what's going on. And I'll give that a frequency of 1 Hertz. Now let's detect the edge of this, so when the ramp suddenly goes down. So I'll do that with a delta object, which is a which shows all the changes in the sample, and then is less than 0. And now I'll create a click object, mc.click. And if I send this to the scope, you can see that there's only 1 click. And that's because all of these ramps have the same phase. So really we want to spread out the phase. So I'll do that with a spread from 0 to 1, and I'll send that to the right inlet of the phaser. And this right inlet governs the phase of each of these ramps. So I'll click this and notice what happens. Now these ramps are not in time, they're asynchronous. But this density is actually effectively 30 Hertz. So really we need to divide it by 30 to reflect what's going on there. Now you may have noticed that we've actually got a slightly lighter patch here, because we'll have 1 channel with a phase of 0 and 1 channel with a phase of 1. And 0 and 1 are effectively the same phase. So we'd actually have, in order to do this properly, we need to spread between 0 and 29/30ths. But actually, let's just rebuild this whole thing using Gen, because Gen is efficient, and yeah, it might be new and useful to a lot of you guys. So first we'll create an mc.sig at trans30, and we'll send this to an mc.gen with a tilde. And we'll go in the gen patcher and delete all that rubbish. And create an in one. And so this will be our signal. And this is going to go to a phaser. And then we'll create the delta of that. Is it less than 0? And then that can go straight out. But in order to change the phase, we need to plus a number between 0 and 1. And then, but we need to wrap it between 0 and 1. So we'll create a wrap 0 to 1. And what goes into this right inlet of the plus is effectively the spread 0 to 1 that we had using the mc.phaser object. So the way we'll create this is using MC channel and MC channel count. Now the channel numbers start from 1, but the first channel needs to have a phase of 0. So we'll actually have to minus 1 from each channel. Our channel count will be 30, because we have 30 channels. And then we'll just times these two together. Yeah, so we actually need to divide 1 by the channel count. So we'll do that with the exclamation mark divide by 1. So we're dealing with 30ths. So we'll have, so if we have channel 1, we'll get 0 times by 1 over 30 is 0. If we have channel 30, then we'll get 29 here, and then 29 times 1 over 30 is 29 30ths. So we won't have the same problem that we had with the spread. Yeah, so we won't have 2 channels with the same phase. Right, so I'll put that in here, and let's have a look at what's coming out of the gen object with a scope. So we've got a very dense load of clicks there. I've forgotten to divide this by 30. And yeah, so there we have 30 clicks a second. So now onto the granular part. We'll delete this, and we'll create another mc.gen tilde object, and we'll just create a mixdown object now, and we want to end up with stereo. So mixdown 2, and then mc.unpack 2. And there we go. And we want to actually randomize the panning of each grain or of each channel. So the way we'll do that is like this. So we'll create a bang, Uzi, and we want 30 bangs. And we want a random number between 0 and 1. So I'm going to use VS between 0 and 1. If you don't have that, then I suggest trying to find that object on Maurizio Ghiri's website. But you can also just do it by creating random, let's say 10,000, and dividing that by 10,000 with a dot at the end to make it a float. So I'll do it that way, and we'll need an mc.sig at chans30 at the end, and so the index will be will go to the target channel. And the result will go to the message, to the target. Let's have a look at this through a jit.cell block. Now the stereo position of each channel will be randomized. This mc.gen object is currently the default patcher, so these clicks will just go straight through, and you can hear what it sounds like just with the clicks. If I take that down a bit, oops. So they're even, but they're spread out across the stereo field. So I'll turn off the DAC, and I'll go into the gen patcher and start building the granular part of this patch. Okay, so I'll delete this, and I'll reference the 2 buffers in the main patcher, so buffer sample and buffer window. And init 2, so init 1 is our trigger, so I'll create a comment saying trigger. inlet 2 is going to be the position in the buffer that we read from. And the numbers coming into this inlet will be between 0 and 1. Doesn't have to be, but that's what we're going to do. And our third inlet is going to be the grain size, and that number will be in milliseconds. And Gem works in samples, so we'll need to convert these milliseconds to samples, ms to samps. Now we'll need a playback object, and for the sample, I'm going to use peak. And peak is pretty much the same as peak in normal MSP. And I'm going to use bound mode wrap. So a value greater than the total number of samples will be just over 0. So 1 greater than the maximum number of samples will be 1. Okay, and we'll need a counter. And that counter is going to start counting whenever it receives a trigger. And the counter is going to count to the number that we get from the grain size. So if the grain size was 100 samples, then we'll count from 0 to 100. And if our position is 0, then we'll be reading from sample 0 to sample 100. But if the position is, say, sample 500, then we want to read from sample 500 to sample 600. So we need to multiply this position. Remember, it's going to be from 0 to 1 by the total number of samples in the buffer. And we can get that from the left outlet of this buffer object here. So lengthen samples. So we'll multiply it by that. And so we'll add the value coming from the counter. Well, so we'll add the count to this position. And we'll feed it to there. And whenever the counter has reached the grain size in samples, then we want it to stop counting. So we could say whenever the counter goes over reaches the final number, so ms to samps minus 1. So whenever it just goes over, the count increment will no longer be a 1, but will be a 0. So we can't just feed it straight back into the increment here. We have to go via a history object. So I think there'll be 1 sample of latency there, which is fine. Okay, so this counter will stop whenever it reaches its maximum, which is the grain size. I'll just neaten up the patch a bit. So currently we have no amplitude envelope, but let's just listen to what we have so far. So I'll just connect that to the outlet and go back into the main patcher. And you see we have 3 inlets to this gen patcher now. So the second is the position. and we need to go from 0 to 1. And I'll just, and it's a signal, so mc.sig at chans 30. Oops, that's 303. And so I'll give that a float value, and we need that to be between 0 and 1. Oops, and 1. And we need something similar with the grain size. But let's make that between 2 milliseconds and, let's say, 300 seconds. We'll just have integers for that. So I'll turn on the DAC. So we're hearing a lot of clicks and pops here. But we've got something, and it's a good idea to test out your patches as you go along. So now let's just create the amplitude envelope, and we'll do that by referencing that buffer window, and we'll use a playback object, and we'll use the sample operator, and that's going to be referencing the window buffer. And we'll just be multiplying the what's coming out of here with what's coming out of the peak object. So we need to say that that's going to be indexed with the phase. So it's always going to be, so we always want a number between 0 and 1 in here. And I'll also use bound mode wrap, just in case we have a number larger than 1 or less than 0. And so we need to divide the number coming out of the counter by the grain size in samples. So I'll use the division operator. I'll take the outlet of that and divide it by the outlet of the MS desamps. So that will always be between 0 and 1. And I'll feed it straight into there and multiply the 2 bits of audio, the 2 signals. Now at this point I would just say save your patch. So you can go File, Save As, let's call it granular gen toot 1, 2, 3. And let's go back to the main patcher and have a listen to what it sounds like. So it's kind of good, but whenever I change this position, you hear various clicks and pops. So currently, we can send a new grain size or a new position to the grain, regardless of whether it's playing or not. It would be useful, though, if we could only output a new grain size once that has received a trigger. And we could borrow that trigger from inlet 1 here. So the object we can use for that is called latch. And so it takes in the value, but it only outputs it when it's received a trigger in the right inlet. So we'll only have a new grain size once the grain has been instructed to play. And we'll do the same with the position. So just take a latch and take the trigger from inlet 1. So let's save this and again listen to how it sounds. Great, so no clicks and pops. So we're basically there. Let's replace these floats with with 2 sliders. Now let's change the knob shape on that slider to the to this indicator. That makes more sense. Let's turn on DAC. So the next step is to be able to control the pitch of each grain. So we'll create a 4th inlet in 4. And it would be really great if we could send it a value in semitones. And we can use something really extreme, like from -100 to +100. And then we can only output it once it's received that trigger. But computers don't really work in semitones that well. So how do we get a useful number from that semitone number? If you go up an octave, you are multiplying your current frequency by 2. If you go up 2 octaves, then you are multiplying it by 2 to the power of 2. If you go up 1 semitone, then you are multiplying your frequency by 2 to the power of 1 over 12. If you go up a fifth, well, a fifth is 7 semitones, so you're going up by 2 to the power of 7 over 12, which is roughly 1.49. So the way we do that in Gen is with an expert object, and we'll use pow2, so 2 to the power of in 1 over 12. So I won't use the spaces. Like that. And then, so currently the counter increment is either 0 or 1, the result of this comparison operator. But if we multiply this by the result of that, then we will affect the speed that we go through the sample. But we need to keep the grain size constant. So whatever we multiply this number by, the 1 by, we need to multiply the grain size by. So we'll create 2 multiplication operators, 1 for the grain size and 1 for the increment here. Okay, so you save your patch and we'll go back into the main patch to see how that sounds so far. And there's one more thing. So currently the counter will only stop when the result of this operator, this comparison operator, is 0. So that is when the counter reaches the final step of its loop. And so the penultimate step will not always be 1 less than the total value. If the increment is 2, then the penultimate step will be the count maximum minus 2 as well. So actually we need to say the penultimate step will be the count maximum minus the grain pitch. So that we'll do that with an expert object. So in 1 minus in 2. That's all it is. And we'll take the grain pitch and we'll plug it into the right inlet of that expra object. And there we go. We can save that and go back to the main patch. So I'll create another MC sig object and another slider. I'll just duplicate that. And we want the range of this to be, well, 200, but the minimum will be minus 100. Enable float output, and we can also have this indicator here. And that's the grain pitch. That's going to go from minus 100 semitones to plus 100 semitones. Okay, and I'll feed that into the fourth inlet of the MC.gen object. So I've got complete control of the pitch. It'd be quite useful if I could have a button to set that to the original pitch. So I can do that with a button and a trigger 100, because the range is 200. So to get to the middle, I need 100. So I'll just quickly neaten up the patch. Okay, we're nearly there. There's just a few more steps. And the first thing we'll cover is the spray. So spray is the randomization of the playback position for each grain. And to create randomization in Gen, we normally use noise. So to create our noise, we'll create a noise operator, and we'll use another latch operator. So we only take that sample of noise once we receive a trigger, and we'll take the trigger from inlet 1, and we'll create a param operator, label it spray. I'm not going to use signals for that because I can't really think why I'd need to control the spray at signal rate, and we'll clip the value of the spray between 0 and 1000, and we'll be working in milliseconds there. So we'll first convert that to samples, and we'll create another latch object, and the noise will create values between -1 and 1. So the playback position might be ahead or might be behind, and we'll just multiply them together. And now we need to just add the value that we receive, the spray value, to the playback position. So so whatever the counter is telling the peak operator to read, we'll just add or subtract the value from the spray. That's it for the spray. And now we'll work on the spread, so the kind of pitch chorusing effect. We're just randomizing the pitch of each grain. So we've created a param spread operator. We'll clip that between 0 and 1200. We'll be working with cents here. 0 to 12 semitones, so we can potentially spread the grain pitches up or down an octave, but we can work with hundredths of a value. So first we'll divide that by 100. And we'll create a latch. And we'll copy and paste that noise sample. And we'll get the triggers. And again, we'll multiply these two together. And then we're simply going to add this randomly offset pitch value to inlet 4. So we'll create a plus object and insert that there. So this gen patcher is now essentially finished. So we'll save it, close it, and go into the main patch. We'll turn on the DAC, and our position's working, our grain size is working, our pitch is working. I'm pretty sure our panorama randomization is working. Our density is our density is working. So I'll just create two attributes by pressing A. And I'll link those to the gen object. And if I lock the patcher, I can select spray and spread. Now, now these need floats, so I'm going to create two sliders. And so this one will have a range of 1000 for the spray, minimum of 0, no float output. Actually, we will have float output because I think gen parameters want floats, or expect floats. And this one, I'll do the same thing. Actually, I won't have float output. I'll create a range of 1200 because that's what we've clipped it to. And with this one, I'll also disable float output, and I'll just convert it to a float in max. So so all the values are rounded, and I'll do that with trigger F. And I'll just insert that there. And then one for the spread. Okay, so I'll turn on the DAC. And maybe you can hear this more clearly with a different sample. So I'll use Cherokee. Drag that Cherokee sample into buffer sample. I'll take down the density. So if I move up the spray, you can hear that the grains are starting all over the place. Well, not all over the place, but only offset by 140 or minus 140 milliseconds. Now, if I dial up the spread, you should hear that kind of chorusing effect as the pitches are randomized. So it can get quite extreme very quickly. But a little bit is quite nice. Now, I find I quite like to control the position and the pitch parameters at once. So I'll bring that down, and to control two parameters at once, an XY pad is ideal. And Max has a really useful sort of XY pad, and that's the nodes object. So I've created one of those, and if I create a message box and show you what's coming out of that second outlet, you can see we've got node 1, it's only one node, and then I've got two floats, and I can tell you that these floats will be between 0 and 1. They'll always be between 0 and 1. So I can unpack everything from there. So we've got nodes, which is a symbol, then we've got the node number, which is an integer, and then we've got two floats, and then something else. But we just want those two floats. So that's element 3 and 4. Yeah, element 3 and 4. So I'll send element 3 straight to position, because our position is mapped between 0 and 1. And element 4 will be between... actually, I can just put that straight to the slider. And element 4 will go to the grain pitch. And first, I'll need to multiply this by 200, because that's the range of my pitch slider. Okay, I'll turn this back up. So that's how to build a granular synthesizer in Max MSP with Gen and the MC objects. So I hope it's been useful, and I hope you've been able to follow along and understand how Gen works a bit better. So yeah, thanks for watching, and I'll see you again at the next tutorial.